All right, hey crew, this is Mrs. Mahalik, and I'm just doing my first recording for you guys for Thursday. So hopefully you guys are having a good day so far. What I want you to do is go ahead and pull out your homework, which is page J. Um, and hopefully you didn't have a lot of problems with that. But while you're pulling out J, I just want to talk to you about a couple things. So Mrs. Baraska is my sub, and what we're going to be dealing with is no tolerance for misbehavior. So if you're stepping out of line or you're not doing what you're supposed to be doing, Mrs. Baraska is either A, going to be removing you from the classroom, or B, she's going to be writing your name down, and I'm going to be taking care of those names every single day because Mr. Mahalik is going to be getting a copy of subnotes. So make sure that you're on your best behavior because, we want to make sure that we're respecting our subs. So I just wanted to make sure that I cleared that up right up at the beginning so everybody knows exactly what the expectations are for your behavior while I'm not there. Um, so I'll be making these videos the night before. And so it's Wednesday night and I'm getting ready to put my son to bed. And so I'm going to try to pop through this pretty quickly. But all you had to do is identify the types of friction in these situations. So I'm going to run through the answers with you, and then I have an answer key, and I'm just going to pop up the answer key for you to look at in case I went too quickly. And then I'm going to talk to you about what the plan is for the rest of the day. That's a little not clear there towards the bottom, but that's okay. Maybe there's something on the lens that's making it be that way. That didn't help, so it's a little better. Okay, so let's look at the first one. A small child trying to push a large desk out of the way. That would be static friction because static friction is when you don't have any sort of movement at all. So a small child would not be able to move a large desk. So static friction. B, a large man pushing a small desk out of the way. Since we're pushing, that is going to be sliding friction. A snow skier skiing down the slopes. That could be fluid friction, fluid because obviously it's traveling through the air, or you could use sliding friction because the skis are sliding against the snow. A water skier skiing across a lake would also be sliding friction, but you also could put in fluid friction because right there we have a liquid. And fluid friction, remember, is not just for liquids, but it's also for air. So keep that in mind. No oil in a car engine would be static friction. If you don't have oil in your car engine, it's going to not work very well. An oiled car engine, that's going to be, you could say fluid friction for the oil. You could say sliding friction, or you could have said rolling friction for the piston, for the ball bearings. Rollerblading down the sidewalk, it's going to be rolling friction, or you could say a fluid friction. Rubbing sticks to make a fire would be sliding friction. A car driving down the road would be rolling friction, or you also could say fluid friction. A swimmer doing laps in a pool is fluid friction. Greased ball bearings is fluid friction or rolling friction. And then it says how many different kinds of friction occur when you ride your bike. Name as many as you can. So really all four types of friction occur. So static friction would be like your feet on the pedal or your hands on your handles. So that would be static friction. You can have fluid friction because oil on your chains, or also just you're traveling through the air. So it's going to be a fluid friction. You can have sliding friction for your brakes and rolling friction for the tires. Okay, so let me just pop up an answer key real quick so you can see the answers um, that I have, and we can go from there. Okay, hopefully that was enough time for you. So what we're going to do next is not what I had originally planned. So what we're going to do today is a series of unfortunate events. So I got an email today, and the email said that we had a little bit of a problem with the eCyber Mission Survey that you took. So what you're going to do is join this new physical science Google Classroom. So this is specifically for your class. So all the videos uploaded in this are going to be specific for just your class, which will hopefully be helpful to you. So you're not like getting a blend of both of them. And I'm going to be posting all of your videos onto my website. So what we're going to do now is you're going to grab one of those Chromebooks of Mr. Maholics, and you're going to log on and you're going to recomplete that eCyber mission survey that we already did. For some reason, it was not transmitted to the people who are doing the survey. And so what I'd like you to do is when you're done, scroll down and make sure that there isn't like a submit button at the very, very end. And maybe when you log in, the whole survey will already be done. And all you have to do is scroll through and hit the submit button. I'm not quite sure what the problem was, but we're just going to give it a try again. So go ahead and do that. And then when you're done with that, what I'd like you to do is in your packet, let me change my screen again, sorry. In your packet, if you turn to page L, there's just an introductory section on Newton's laws of motion. And so this just goes over the 3 laws of motion. Newton's first law, it tells you what it is, and then what it means. The second law, what it is, how or what it means. The third law, what it means. And then what I want you guys to work on is questions 1 through 10. So this will be your homework assignment, is to do 1 through 10 of the critical thinking questions. Just these critical thinking questions. Tomorrow, we're going to do these exercises, but we're not doing that today. So all you need to work on today is these critical thinking questions. So remember, I'm going to create this as an assignment. You need to take a picture. I want to see your name written in ink across this portion of the page, all right? So I want to see that it's actually yours and you aren't copying off of somebody else, okay? Or you're not taking a picture of somebody else's work. So it'll have your name written here, and then you'll take a picture and you'll upload that, and then I'll put that in as a grade for you. Also, I want you to, on Google Classroom, down here, there's going to be comments, and as soon as you're done with the eCyber mission, I'd like you to click done, or to write the word done and then click enter, so that I can make sure that I know that everybody has it done, so I can keep better track of attendance that way. If you have any questions, feel free to put those questions in the comments. Hey, Donnie, do you want to say hi to my 6th period class? Okay. So if you have any questions, make sure you put those in the comments too so that I can address those. So here is, hi. This is my 6th period class. Can you say hi, 6th period?
Hi, 6th period class.
Say, just got out of the bath.
That's pretty much because it's wet.
Hair's wet, all clean. Oh, now I'm wet. Okay, well, hopefully you guys are having a great day, and what I'll do is answer any questions that you have posted on this link. I'll answer them tomorrow. Okay? Hopefully you guys are having a great day. Talk to you later. Bye.